Okay, we're on section 5.5, part C, simple harmonic motion. The periodic motion of things like springs and tides and sound follow a sine wave, so they can be modeled using sinusoidal functions. The frequency is the number of cycles that it completes in a unit of time. Since the period of time is given, the period it gives the time required to complete one cycle, the frequency is the reciprocal of the period. Now, the parent function of sine is 2 pi, so when we find the function's period of any sine function, it's 2 pi over b, so the frequency is going to be the reciprocal of that, or b over 2 pi. So here's a graph. Basically, it represents a spring holding a weight, and the weight it's at rest position is at 0, and it's pulled down and released. And for the first few seconds, it bounces up and down like in a sine wave. So the x-axis, that should say in every tick mark, is 1 second. And part A asks us to find an equation. This looks like an upside down cosine function, so I'm going to put negative of cosine. Its min is at -6, and its max is at +6. So its amplitude is 6. Or you can do max minus min all over 2, and when you simplify that, it's still 6. Now the b value inside the parentheses, remember the 2 pi over b is equal to the period of the function. The period of this looks like it takes 1, 2, 3 seconds to complete the graph. So that's going to be equal to 3. So when we solve this, 3b equals 2 pi, or b is equal to 2 pi over 3. So we can plug that into our function, and that completes our cosine function to fit this graph. Part B, the frequency, remember, is b over 2 pi. So b was 2 pi over 3 over 2 pi. When you multiply by the reciprocal, it's going to cancel down to 1/3. So basically that means it takes 1/3 of the function to complete every second. So by the time 3 seconds are done, it's completed the entire cycle. Part C asks the position of the weight after 2.4 seconds. So its position is the y value. You're going to plug in 2.4 seconds for the t. So that's the time. Put your calculator in radian mode, and when you solve that, you get negative 1.85. So that represents 1.85 inches below the at rest position. And it's below because it's negative.